Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 29th, 2025, about 2 days ago. The big result is simple and bold. This paper delivers up to 22.58 times speedup without any performance drop and up to 57.51 times when combined with key value cache. The paper is titled Learning to Parallel, Accelerating Diffusion Large Language Models via Adaptive Parallel Decoding. And as we'll see later, the gains come from smarter parallel decoding, not bigger hardware. In short, a tiny learned filter and an end-of-text prediction signal make diffusion language models finish sooner while keeping answer quality steady. Alright, the intro set the motivation for adaptive parallel decoding. Figure 1 shows throughput and accuracy on GSM 8K with 4 setups, so the comparison is clear. Baseline decoding runs at about 0.54 tokens per second, while Learn2PD reaches 6.63, and adding end-of-text prediction doubles that to 12.26 with accuracy preserved. Integrating key-value cache pushes throughput to 16.37, which corresponds to about 58 times faster, with only a small accuracy dip. So the previous figure highlighted speed gains. Figure 2 shows why headroom exists by charting step gaps, which mean how many decoding steps pass after a token is first predicted correctly until it finally gets unmasked. The left panels display histograms for GSM 8K and human eval, and most mass sits beyond 10 steps, signaling heavy redundancy. The right panels plot samples where red marks the first correct step and blue shows the actual unmasking, revealing long delays. These patterns indicate widespread unnecessary remasking that a smarter policy could avoid. Well, Figure 3 lays out the decoding pipeline and the adaptive alternative. The left panel illustrates extremely greedy parallel, which compares predicted tokens to a reference answer and only remasks mismatches, so correct tokens advance immediately. The right panel presents Learn2PD, where prediction confidences feed a tiny filter that decides which positions to remask at each step. This learned filter approximates the oracle behavior without ground truth, enabling fast parallel progress while keeping quality intact. So the previous figure described the adaptive decoding loop. Figure 5 shows the end-of-text prediction policy that sits alongside Learn2PD and checks each decoded block for an end-of-text token. When the checker finds end-of-text, the system assigns end-of-text to all remaining positions and halts, which prevents wasted iterations. If no end-of-text appears, the iterative steps continue. This simple stop rule trims the long tail of padding work, so throughput jumps especially at long generation lengths. So, while Figure 5 described the stop rule, Table 1 reports end-to-end throughput, speedup, and accuracy across tasks and lengths. The table shows the biggest gains at generation length 1024 because end-of-text prediction removes padding waste. For GSM 8K, tokens per second rise from about 0.5 to 6.6 with Learn2PD and to 12.3 with end-of-text prediction, delivering roughly 23 times speedup with accuracy near 80. For MBPP, the combined method reaches about 17 times speedup with only minor score changes. So while Table 1 showed end-to-end gains across tasks, Table 2 focuses on compatibility with key-value cache. The base Learn2PD and end-of-text prediction row reaches 12.26 tokens per second, about 22.6 times faster, with a score near 79.8. Adding dual cache jumps to 31.23 tokens per second and 57.5 times speed with a small score drop. Prefix cache lands at 14.79 tokens per second and 27.2 times, with a score of 77.7. Alright, the previous table emphasized compatibility with key-value cache. Table 4 compares generation lengths, and the pattern is clear. Longer outputs yield larger acceleration, while scores stay comparable. At length 128, Learn2PD and end-of-text prediction reach about 3.4 times. By length 1024, Learn2PD alone hits about 12 times, and the combined method climbs to roughly 23 times with a score near 80. Okay, 2 takeaways stand out. A tiny learned filter with end-of-text prediction turns diffusion decoding into an adaptive, case-by-case process, delivering about 23 times speedup with no accuracy loss, and up to 57 times with key-value cache. The broader implication is practical. Minutes-level post-training that slots into existing systems. That's it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.